Hello everyone, and welcome to another mini sky tonight. So I've had a couple of viewers often throw out some different terms intermixed, and I wanted to clarify some of these terms mean different things, and to also clarify what these objects are in the sky. And yeah, they're kind of similar, but they do have different categories. So I wanted to clarify all these different categories of these quote unquote space junk items. So let's dive into it. First of all, the three topics I wanted to cover over are comets, meteorites, and asteroids. Those are often terms that are tossed around, intermixed among the sentences, and even though many people misuse them, I wanted to clarify what they are and how to properly use the terms. So let's dive into comets and what they are. Comets are balls of icy rock and dust and all sorts of materials that exist far outside the orbit of Pluto in what is known as the Oort cloud. It's basically the leftover junk from the solar system creating. And these objects sometimes get into our solar system and they create these beautiful objects that we can see in the sky that have these long, gorgeous tails, and they are often very random. So what do they look like up close? Well, they're just big rocks. In fact, one of the fun things I often love to do with some of my students is what is called a kitchen comet. In fact, you can make your own little comet in your own kitchen. You just need some dry ice, some dirt, some ammonia, some water, and basically mix it all together in a bag and put a fan blowing on it to represent solar wind, and you practically have a comet. Basically, comets are sometimes thought to be the seeds of our planet in terms of water. So what makes up a comet other than it's just a big, huge block of rock? Well, when it's far out beyond our sun, it's just that, because it's so cold. But once it starts getting close to the sun, whether it's knocked into orbit or something of that nature, it changes incredibly and it becomes a beautiful sight to see. So when it gets close to the sun, things start heating up. Because like dry ice, it likes to be kept at cold temperatures. And since these chunks of rock and ice, some of that ice is gas that's frozen because it's out in the farthest reaches of space, once it starts getting closer to the sun and starts heating up, that gas starts to vaporize. And it creates these beautiful displays that have these big, huge cocoons, I sometimes like to call them, with these long tails. And they're quite a sight to behold. So let's kind of take a look at the anatomy of a comet when it starts getting closer to the sun. So what you have is the big, huge cocoon, as I like to call it, or its proper term is the coma, that basically is all the gas starting to vaporize outward and creating like the shell around the original nucleus. The nucleus or a comet is roughly between 1 to 10 kilometers, whereas in the coma itself can be over 50,000 miles. So it's a big, huge cocoon dust of ice and dust and gas, basically encompassing the original comet. From there, you get what is also known as the dust tail. Basically, as this thing is going several 100,000 miles a minute through our solar system, some of that material that's being ejected from the coma is going behind it. The term "eat my dust" means a whole new meaning because these things are traveling so fast through the solar system, it leaves a huge, gigantic trail of dust behind it. And the dust tail is usually like ice, dust, rock, all the junk. So often those tails are seen as white, and those are pointed in the direction of the orbit of the comet. Whereas in the other tail, it kind of looks like this brilliant blue tail, or sometimes a rather faint blue tail. And that blue tail is what is known as the ion tail. Now, the ion tail is ionized gas. Now, since we're dealing with the solar wind is filled with charged particles. And those charged particles interact with the gas in the comet and ionizes them. And when it does that, it creates this beautiful color display that goes directly perpendicular or directly parallel to the direction of the sun. So the ion tail points literally in the same direction as to where the sun is going, whereas in the dust tail is in the direction of which the comet is going around in its orbit. So that's the basic anatomy of what a comet is. So let's kind of take a look at some comets. So like this is a current comet, Comet Swan, and you can kind of see the ion tail near the top right there, those blue flurries right there, and the funky wavy thing behind it is the dust tail. And of course you can see that beautiful blue hue that kind of creates the coma. So what are some famous comets? Now, well, for example, many comets in the past were actually considered broom stars because, well, they kind of look like a big, huge broom with a star at the top of it. And many people, when they saw these broom stars, they realized they were messages from the heavens, and sometimes they were harbors of, bearers of horrible things. I don't want to list all the horrible things that often followed it, but sometimes they were indicators for other different things. For example, if you look on the coin of an old denarius, you'll see a symbol of a comet. That is known as Augustus's comet because Julius Caesar, when he was assassinated, a couple years after that, when Caesar Augustus came into reign, he noticed a comet. He was trying to say, hey, look, Julius Caesar is now into the heavens and this is his symbol. And he put his comet on the back of a coin. And of course, we cannot mention the term comet without the famous Halley's Comet that has an orbit of 76 years. It's the most consistent comet that we know of to date, that several people have recorded it. In fact, I think the next viewing of Halley's Comet is in 2061. So let's get through 2020 so that we can survive to be able to see Halley's Comet again. I know this year has been rough, but hang in there. And of course, the recent for NASA is Comet Tempel 1, where they sent a space probe to smack into the side of the comet to figure out what's inside a comet. And well, yes, there was the incident where an astrologer sued NASA because hitting the comet caused chaos and disorder in their charts. And needless to say, the lawsuit didn't go very far because keep in mind that this spacecraft was about the size of a coffee table, maybe at most. And it smacked into a comet that was about a city size. Yeah, it barely did any good. So, you know, but we did learn a lot from this impact to where some debris was launched out, and that debris, using the Hubble Space Telescope as well as different other spacecraft, we were able to take images of the debris and analyze it. So analyzing this debris kind of gave us some indicators as to what is beyond Pluto in the Oort cloud, as well as what is the basic anatomy of many comets. Another famous comet is Comet Shoemaker Liddy number 9, which is a huge comet that broke into several pieces and impacted poor Jupiter back in the 1990s. And it left some huge scars on Jupiter. So could these events happen to us? Yes, but they're incredibly, incredibly, incredibly rare. Fortunately, we have planets like Jupiter who does get the majority of the comets, as well as comets tend to be rare when they get knocked into our solar system. But from comets, we do get some unique items known as meteorites and meteors. Meteors and meteorites are two different things. A meteor is basically a shooting star, a streak across the sky because that space debris gets burned up in our atmosphere and that's it. Sometimes they're called fireballs because sometimes they could be big enough to where they make this big, huge streak across the sky, but they only last for a few seconds, whereas in comets, last for several weeks. So that is a big difference. Sometimes people think, oh, it's a comet in the sky. How long did it last? A couple of seconds? No, it's not a comet. Comets last several weeks because they're far out in space, whereas this is hitting our atmosphere and burning up. So a meteor, or sometimes called a shooting star, is what streaks across the sky. In fact, several meteor showers are the result of comets coming by. So sometimes the yearly cycle of meteor showers is the result of us going into the leftover debris of a comet. Remember when I talked about the dust tail that leaves all this dust and stuff behind? And the term "eat my dust" means it's a whole new thing? Well, I sometimes like to call comets the tailgate parties of the solar system. Tailgate parties are fun, they're big events, but when the party is over and the comet has left, they leave a bunch of mess behind. And it's our atmosphere that collects it and burns it up. So hence why we have meteor showers. So now the difference between a meteor and a meteorite is one that's either big enough and or is made of a type of material that can survive going through our atmosphere and actually hits. So there are different types of meteorites that we have discovered. There are stony meteorites, which basically is 94% of what usually falls. They have silica balls, they contain aluminum, magnesium, silicon, and they impact and they kind of look like an average rock. There are some that are iron, and then there are some that are kind of a mixture of the two, and they have weird different crystallizations because of all the different metals that are inside. So how do we find these meteorites? Well, sometimes they leave a big explosion and they leave like this big, huge hole and a bunch of dust. And sometimes you just have to be lucky to be at the right place at the right time to find it. Or in some cases, like if you live out in the middle of Arizona where it's nothing but huge lake terrains and beds that are similar in design, and then all of a sudden you just see a chunk of rock that looks completely out of nowhere, unsimilar to everything else, chances are it might be a meteorite. And then of course, if you're up at the North Pole and you come across a rock, well, guess what? Chances are it's a meteorite because nobody brought a rock up to the North Pole. So many of the meteorites that have been discovered and confirmed as meteorites came from the poles because, well, when you're in the middle of the ice and then all of a sudden you come across a chunk of rock, well, there's a meteorite from space. And sometimes those meteorites do hit different things. Like this is the result of a poor couple that was coming back from a drive-in movie when all of a sudden a meteorite smacked into the back of their car, and the meteorite was found in the back of their car. I don't want to know the insurance claim for this poor car. And of course, this is the back of another one was the back of a Pontiac coupe where it literally went through the roof of the car and back through the back seat. Crazy. And of course, this poor lovely woman in Kentucky who was just laying on her couch and one went through her roof. And it smacked her and left a big, huge size bruise on her side. So she's just sitting in her home and something came through the roof. Crazy. Now, notice how small some of these things are. They're roughly about the size of your fist or your hand, so they're really tiny. They can still do some damage, but they don't do anything catastrophic. It's once you start getting to things that are roughly about the size of a school bus or bigger, then you start getting problems. For example, Meteor Crater was roughly about the size of a school bus when it originally went through our atmosphere and impacted thousands of years ago and left this big, huge, several-mile hole. So meteorites can be devastating determining how big they are. And of course, the biggest one that we are familiar with is in the Yucatan Peninsula, which left this huge gigantic crater several miles long, or several miles in diameter. And some of it wasn't even discovered until we actually had satellites. So this was a huge, huge crater. In fact, astronomers believe and some historians believe that this was the crater from the meteorite that ultimately ended the dinosaurs. It's a working theory, but it's understandable. So those are comets and meteorites, and they often are very connected with each other, whereas asteroids are a whole different ballgame. Now, asteroids and meteorites are often intermixed. I mean, Hollywood has intermixed them constantly. But in this particular case, we're just going to look at asteroids as planets that should have been. Whereas in comets are the leftover debris of the solar system, asteroids technically are like the materials that could have formed into a planet but didn't. So where do most of the asteroids lie? Well, we discovered most of the asteroids roughly around about in 1801 when an astronomer with the last name of Bode was trying to figure out, okay, where are the next planets? Because he was trying to help search for some of the next planets in the line. Because visually, you can't see Uranus, Neptune, or Pluto with your naked eye. You can see Mercury, Venus, Earth, Mars, Jupiter, and Saturn with your naked eye, whereas in Uranus, Neptune, and Pluto, it requires a telescope. So he was trying to mathematically predict where the next planet should be. And with his formula, he was pretty close. For example, on Mercury, he predicted it had roughly an astronomical unit of 0.4. It's roughly about 3.9, so pretty darn close. And for Venus, 0.7, Venus is 0.72. And so on. So he was in the rough ballpark of where some of these next planets should be. And then he was trying to figure out, okay, given my formula, there should be something here at roughly about 2.8 astronomical units away from the sun. But there's nothing there. What could it be? Well, it was roughly in 1801 when we discovered the big asteroid known as Ceres, which is now considered a dwarf planet. It was discovered in the 19th century by, I apologize if I butcher his name, I don't know Italian names very well, Giuseppe Piazzi, I believe that's how you pronounce his name. He was the one that first discovered Ceres using several photographs over the long period of time. And most asteroids inhabit the area between 2.1 astronomical units and 3.3 astronomical units away from the sun. So like this blank space between Mars and Jupiter. And we noticed that asteroids have this planet-like orbit with like low eccentricities, meaning like it's not tilted or anything, and it has close to circular orbits around the sun. So they think that should have been a planet once upon a time, but astronomers believe that maybe it's the gravitational pulls from Jupiter and the sun that caused it to not form. A few years ago, only about 5,000 of them were being discovered each year, but today over 260,000 asteroids with known orbits exist, and we're finding even more and more with newer technology. So here's kind of a synopsis of some of the bigger ones that we have discovered so far. As you can see, many of these smaller asteroids are potato-shaped, so hence why they're not considered planets, because the three rules for a planet are: 1, it orbits the sun; 2, it's close to a sphere in shape, so forget flat Earth, it's a sphere. So hence why Ceres is considered a dwarf planet, because she's close to a sphere in shape. And lastly, it has to clear its orbit of objects as big as itself. That's why Ceres is considered a dwarf planet, because since she exists inside the center of the asteroid belt, there are objects similar to her size that she hasn't cleared her orbit from. But she still is a spherical object that is inside the asteroid belt. Now, keep in mind, some of these objects are tiny. For example, one particular asteroid is roughly around about 19 kilometers in its longest length. The reason being why you have to measure some asteroids in different diameters is because, well, they're potato-shaped, they're weird shaped, they're not exactly spherical or circular or square in particular. They have weird, funky shapes, so often astronomers measure them by length, width, and height in different diameters. And for some of the smaller ones that we have discovered, they're roughly a few kilometers across. Just for size comparison, Texas is over 1,000 kilometers in length. So that gives you a rough idea that many of these little objects can fit inside the state of Texas. So these are tiny things. And many asteroids, like for example, this is the example of Ceres, are discovered using time-lapse photography, where you take a picture one night, take a picture another night, take a picture, take a picture, take a picture over a course of several days, and then you compile those pictures together and you notice something moves. Because since the stars are so far away, chances are their stars are not going to move. Whereas if an object is close by that's in orbit over a course of period of time, it will start to drift. In fact, here's another example. This isn't a galaxy that we're taking a picture of, but that little line that's over to the right of the galaxy is an asteroid that's just in our solar system and it's orbiting. Now, let's get rid of some major misconceptions here. Many people think that going through the asteroid belt is kind of like the scene from Star Wars where Han Solo is trying to escape some of the TIE fighters and they're having to dodge in between all these different asteroids and hoping not to get hit. That is not the case for our solar system. The average distance between some of these asteroids is about several hundred miles. So you don't get to see some of these asteroids really up close and personal. And since there's a huge amount of space for the asteroids to occupy, their density is really small. So yeah, and also keep in mind that the total mass of all the asteroids put together is less than the mass of Pluto. So hence why it's not like a scene from Star Wars where they over-exaggerated an asteroid belt. In our particular case, it's like, oh, there's one. Several miles later, oh, look, over in the distance, there's another one. Nothing dramatic, sorry. So let's look at the different types of asteroids. Like there are different types of meteorites, there's different types of asteroids. The most common is C-type, which are these dark, low reflectivity asteroids, which have a high carbon content. So hence why they have such a dark color. Some astronomers compare them to like charcoal. Another type of asteroid is a silicon base, which have a lot of olivine or silicate materials, and they are very reflective. And then of course you have M-type of asteroids, which are heavy in iron and nickel. And these are the ones that are many aerospace engineers and astronomers are interested in to go exploring because they're rich iron and nickel content to be able to mine for it and not have to constantly mine in our planet and use up all the resources. Now, majority of the asteroids lie between Mars and Jupiter. However, there are a few exceptions to the rules. There are near-Earth orbit asteroids as well as what are called Trojan asteroids. They kind of lie in the orbit of the gas giants before and after the planet because of the gravitational pull that these gas giants have. And they lie within what is known as the Lagrange points. Kind of like what we talked about in a previous episode, Lagrange points are basically points to where gravity cancels out and an object can exist to be able to orbit. So in the case of, for example, Earth has roughly about 5 Lagrange points, one of which we are not sure if something does exist over on the other side of the sun. Chances are it's probably nothing, but we do know of Lagrange point 4 and 5 that many of the near-Earth asteroids are located, and Lagrange points 1 and 2 is where we put most of our satellites into orbit. So those are the differences between comets, asteroids, meteors, meteorites. I know they often get intertwined and intermixed, but they are different types of materials as well as different objects in our sky. And hopefully we'll get to see a few of these different objects as the months go by. If you have any questions or comments, leave them down in the comments below, or if there's a topic you would like for me to cover over, let me know as well. If you would love for me to be able to do like a live presentation of like a sky tonight to show you some of the different constellations and everything, as well as to be able to ask live questions, I would love to be able to do that. Just let me know down in the comments below and I can schedule a time. If you're looking for some fun activities for your kids, futurereadysa.org has a huge list of fun activities and badges for kids that between the grade levels, second grade and all the way up through college, that allow you to do some fun activities, to learn different things, and to earn badges as a sign of self-pride. So if you would like to check out one of the badges that we do here at the Scobee Education Center, one of them that I have personally done is the Astronomy badge, and we would love for you to be able to check it out. Until next time, stay safe, stay healthy, and as always, never stop learning.